When two people apply the same volume of the same fragrance, the results often diverge. Hours later, one might carry a warm amber scent, while the other gives off a sharp green odor. We usually treat perfume as a finished product, a static recipe of ingredients captured in a glass bottle. In reality, the liquid remains inactive while bottled. It requires a second catalyst to express its full range. The final smell is the result of two forces: the physical laws of molecular volatility and the unique biology of the person wearing it. Understanding how a fragrance evolves requires looking at what happens when these laboratory chemicals meet human physiology. The olfactory pyramid is a map of molecular weights and evaporation speeds. Top notes consist of the smallest, lightest molecules, such as citrus and herbs. These float away from the skin within the first 15 minutes. These notes provide an immediate burst of scent, softening the transition so the heavier elements don't feel overwhelming when first applied. Heart notes are medium-weight molecules, like florals or spices. These emerge as the top notes fade and typically last for several hours. They act as a bridge, masking the initial sharpness of the base ingredients while they settle into the skin. Base notes are the largest molecules, like woods, resins, and musks. These act as the anchors of the composition. These heavy molecules also function as fixatives. Their physical density creates a barrier that slows down the evaporation of the lighter notes above them, extending the life of the scent. This makes perfume an engineered time-release mechanism, where the sequence of smells is dictated by the mass of the molecules. While the physics of the molecules remain the same, the skin acts as a living surface that disrupts this planned timeline. On oily skin, natural lipids trap the molecules and slow their release, making the scent last longer. Dry skin lacks this oil barrier and tends to absorb the perfume oils, which forces the notes to evaporate much faster. Temperature also drives the process. Warmer skin accelerates evaporation, burning through the top and heart notes and reaching the base of the pyramid much earlier than intended. The skin's acid mantle can further shift the profile. Different pH levels react with specific molecules, which can make green notes smell sharper or cause florals to become sweeter. Diet and hydration play a role as well. Pores secrete odors from spices or medication, creating a natural scent profile that is unique to the individual. These natural secretions mix directly with the perfume's oils, resulting in a scent profile that differs from what was in the bottle. Because of these biological factors, a fragrance cannot perform the same way on every person. After several hours, the lighter notes have evaporated, leaving behind the final stage of the perfume's life, the signature. This signature is the result of the heaviest perfume molecules mixing with your skin's own oils and chemistry. This is why testing a fragrance on a paper strip provides an inaccurate preview. Without the heat and oils of the skin, the perfume never moves through its intended stages. To see how a fragrance actually performs, it must be applied to the skin and allowed to interact with your body chemistry for several hours. Perfume is not a mask, it is a collaboration, where the wearer provides the final ingredients necessary to complete the scent.
Ruta olfativa. Descubre tu aroma.